Okay, so in part one of complex numbers, we're going to talk about basic terminology. Then we're going to look at how to add and subtract complex numbers, and then we're going to look at how to multiply complex numbers. Okay, so let's talk about the terminology, and some of this will be a review from a previous course. But remember the imaginary unit. Let's talk about the imaginary unit. All right, so the idea behind this came about, remember, when we talked about taking the square root of, let's say, -4. So remember, the square root of 4, the principal square root of 4 is 2, because 2 times itself is the radicand 4. But there is no real number times itself that's going to be -4. So if you say -2 times a -2 is a positive 4. And so what we had to do was define the idea of an imaginary unit. So remember what we did was we talked about the square root of a -1, square root of a -1, and if you put square root of -1 in your calculator, you would get something like a domain error or undefined. But we talked about the square root of a -1 being the imaginary unit I. And so when we talked about the square root of a -4, we saw that was equal to the square root of a -1 times 4. And we can write this as a product of two radicals. So the square root of a -1 times the square root of 4. And the square root of a -1 is I. And the square root of 4 is 2. And so remember, we write this as just 2i. So the square root of a -4 is 2i. Now, let's go back and look at this. So if we know that I equals the square root of a -1, and remember in a previous course when we solved radical equations, in particular square roots, to get rid of the square root, we square both sides. So the opposite of square rooting is to square. So basically, and remember, what you do to one side, you do to the other. So if I were to square the right-hand side, then I would need to square the left-hand side. And so I get I squared is equal to, and then remember the square and the square root onto each other, or you can just think of it like this. Remember, this means the square root of a -1 times the square root of a -1, which is just -1. Now the mistake people make here, recall, is that you got to be careful when the radicand is negative. You can't do this like we would do something like this. The square root of 3 times the square root of 2, and we know that is the square root of 6. So if the indices are the same, then we can just multiply the radicands together. But that's only true, this is only true if the radicand is positive. So if the radicand is negative, we can't use this property. So we have to say, in this particular case, that the square root of a -1 times the square root of a -1 is just -1. Just like we talked about the square root of 6 times the square root of 6 is just 6. The square root of 8 times the square root of 8 is just 8. So all this is a review from a previous course. Now, so another way of thinking about this, rather than looking at it this way, the square root of a -1 to the square root of a -1 is just -1, is to remember that the square and the square root undo each other, and so you're left with -1. So there are a couple of things you have to remember from this little part here. You have to know that I, the imaginary unit I, is equal to the square of a -1, and you have to know that I squared equals a -1. Okay? So that part you have to know. All right, now let's talk about the idea of complex numbers. All right, complex numbers. So a complex number is a number written in this form, a plus b I. So a complex number is a number written in this form, a plus bi. Remember, I is the imaginary unit, the square root of a -1. And a and b can be any real number. So a and b are any real number. All right, so for example, these are examples of complex numbers. Examples of complex numbers. All right, so 3 plus 6i is a complex number. A in this case is 3. B in this case, remember B is a coefficient of the imaginary unit, so B is coefficient of I. So B is 6. You can have something like 6 minus 2/3 I. So A in this case is 6. B in this case is negative 2/3. You could have, let's say, 8 plus 0i. That is also a complex number. So 8 is A and 0 is B. You could also have 0, let's say minus 2i. So A is 0, B is negative 2. So these are examples of complex numbers, and notice that each of these numbers are written in the form A plus BI. Now the constant 3, the constant 6, the constant 8, and the constant 0, that's called the real part. So the real part. So as we go through the discussion of adding and subtracting and multiplying, I'm going to use the word the real part. So these are the real parts right here. So the constants. So the constants are the real part. The imaginary part is B. So A is called the real part. So A is called the real part. And B is called the imaginary part. All right. So if I go ahead and list these again, these examples. So B in this case would be 6. So the imaginary part is, in these examples, 6, negative 2/3, 0, and negative 2. All right, so those are the imaginary parts of the example of these 4 complex numbers. All right, now we also need to know. I'm going to go ahead and write these examples again. So 3 plus 6i, 6 minus 2/3 I, 8 plus 0i, and then 0 minus 2i. So we also need to know that, you see this example right here, the 8 plus 0i? So the 8 plus 0i, if you remember 0 times I is 0, so that's just 8. So what I want you to recognize is that 8 is a real number. This is a real number. So every number you dealt with in the past, 2/3, the square root of 6, 2.7, negative 6, 4, negative 4/3, things like that. So every real number, these are all complex numbers. So these are all complex numbers because they can all be written in the form, they can be written in the form A plus BI. Now, you may say, well, how is that possible? Well, if these are your real parts, remember real numbers, these are your real parts, I can write 2/3 as 2/3 plus 0i. So every real number can be written as a complex number as long as b is 0. So the square root of 6 plus 0i, 2.7 plus 0i, and so on. Okay? Now, let's look at this one here, 0 minus 2i. So 0 minus 2i is the same as negative 2i. So if a is 0, or if we just say a equals 0, then we get then a plus bi just becomes bi. And if a is 0, this number is called a pure imaginary number. That's called a pure imaginary number. So this complex number right here is also called a pure imaginary number. All right. So one more thing before we look at some examples. Remember, we now know that every number we've dealt with is called a complex number. So every number we dealt with is called a complex number. And it's called a complex number because I can write every number in the form a plus bi. Now, every number you dealt with in the past, up until now, has been a real number. So I can write every real number, right here, I can write every real number as a plus 0i, a plus 0i, a plus 0i, and so on. Now, a complex number can be real or it can be an imaginary number. Okay, so a complex number is either a real number, which is what you are familiar with, this right here. You're now going to be familiar with this, although you talked about this in a previous course when you solved quadratic equations. And examples of real numbers would be something like this. 6 plus 0i, 2.8 plus 0i, negative 4 plus 0i, and so on. So a complex number that's real, I want you to notice that b is 0. So b has to equal 0. An imaginary number, a complex number is an imaginary number if it's written in this form, a plus bi with b not equal to 0. So again, a real number can be written in the form a plus bi, but b equals 0. Here, an imaginary number is written in this form a plus bi, but b is not equal to 0. So examples would be negative 2 plus 5i, 6 minus 3i, and so on. So these are all these are complex numbers, but in particular we call this a real number because 6 plus 0i is just 6, 2.8 plus 0i is just 2.8, and these are called imaginary numbers because b is not equal to 0. Alright, now going back to our review here, remember in particular, if you remember that a is called the real part and b is called the imaginary part. Okay? Alright, now let's see. Okay, so let's talk about adding complex numbers. Alright, so adding is the easy kind. So let's suppose I want to add, let's say perform the indicated operation. Alright, so we're going to talk about an easy example first. So the easy example would be 2i plus 3i. So the coefficient of I is 2 here. The coefficient of I here is 3. It's kind of like saying 2x plus 3x. So in terms of combining like terms, these are like terms because they both contain x to the first power, x to the first power. So remember, this would just be 5x. Same idea here. Even though x here was an unknown variable. I, we know, is a number, square root of negative 1. We can just, again, treat it just like this. So 2i plus another 3i would just be 5i. Okay? So if I had this example, let's say I had this complex number 2 plus 3i, and I'm adding it to this complex number 5 plus 6i. So I'm adding these two complex numbers. So basically I can add, so I'm adding here, so I can add the real parts. Notice I use the word real part. The real part here is 2. The real part here is 5. So it's kind of like just saying combine like terms. You're just combining like terms. So the combine like terms. Alright, but when combining like terms, I'm going to combine the real parts. So 2 plus 5 is 7. And then 3i plus 6i is 9i. Right, so 3i plus 6i is 9i. And then they'll usually ask you to write this in standard form. Now, standard form of a complex number looks like this: a plus bi. So we put the real part first and the imaginary part second. Okay. All right. So number 3. So adding is easy, and let's suppose we had this. Let's suppose we had 6 minus 8i plus a negative 2 plus 3i. So let's say we had that. So again, you're just gonna add the real parts. So 6 plus a negative 2. If you need to use your calculator, use your calculator. 6 plus a negative 2 is 4. A negative 8i and a positive 3i. So add their coefficients. Negative 8 plus 3 is a negative 5, so that becomes a negative 5i. So there's your answer. So it's written in the form a plus bi, where a is 4 and b is negative 5. All right, so just leave it like that. Same thing here. Just leave it like that. All right. So we put the real part first and the imaginary part second. Okay, now let's talk about subtraction. So let's kind of review something with regards to subtraction. So we remember in the past when you had something like 2x minus 3 subtract 4x plus 8. All right, so remember we did this. So you could think of this subtracting this polynomial as distributing a negative 1. So multiplying both terms in here by this negative 1. Or you can think of it as adding the opposite. All right, so it's another way we discuss this. So this would become 2x minus 3, and then distributing in a negative 1. Negative 1 times 4x is a negative 4x. A negative 1 times a positive 8 is a negative 8. And then we combine like terms. 2x minus 4x is a negative 2x. A negative 3 and a negative 8 is a negative 11. The same idea applies with the next one. Suppose I had this. 5 minus 2i subtract 8 plus 6i. Alright, so 5 minus 2i, so I'm subtracting from this complex number, I'm subtracting this complex number. So again, the first thing you want to do is to, when you're subtracting, is to get rid of this parentheses right here. And remember that right here, if you need to think about it this way, that's understood to be a negative 1, so you're going to be distributing a negative 1. So think of this as a negative 1, and you're distributing a negative 1 through there. So you can multiply every term that's inside this parentheses by a negative 1. So this becomes 5 minus 2i, and then a negative 1 times 8 is a negative 8, and then a negative 1 times a positive 6i is a negative 6i, and they combine like terms. And remember, you want to put it in standard form, a plus bi. So 5 and a negative 8 is a negative 3. A negative 2i and a negative 6i is a negative 8i. And so there's your answer. Alright, and then number 5, suppose you had negative 6 minus a negative 8 plus 2i minus, let's say, a negative 18 minus I. Let's say we had that. All right, well, same idea. You're going to get rid of these parentheses. So you see, addition was easy. Addition is easy. Subtraction, you're going to have to use your distributive property. So here I'm going to distribute the -1 here. Remember, think of this as -1, and you're distributing -1. You're going to distribute the -1 here as well. Okay, so we get -6. A -1 times a -8 is a +8. A -1 times a +2i is a -2i. A -1 times a -18 is a +18. A -1 times a -i is a +i. And then you just combine like terms. -6 could, if you add the real parts, -6 plus 8 is 2. 2 and a +18 is 20. I get 20 here. A -2i and a +1i is a -i. And so there's your answer. And it's in the form a plus bi. So a is 20. B, remember, notice this now, that's going to be important at some point. B is a -1. All right, so B in this case is -1. A here is -3. B here is -8. All right, so that's adding and subtracting complex numbers. Now let's talk about multiplying complex numbers. All right, now one thing you didn't need with regards to multiplying complex numbers is the fact that I squared equals a -1. So I equals the square root of -1. I squared equals a -1. All right, so you're going to need that. Okay, so this is going to be number 6. So number 6, let's suppose you had 3i times 2i. We're going to start easy with this one. So 3i times 2i. Now remember, this time you're multiplying, you're not adding, so don't say that is 5i. And don't even say this is 3 times 2 is 6, and this is 6i. So this is not 5i, and this is not 6i. So remember, you're multiplying. So it's kind of like saying 2x times 3x. So 2 times 3 is 6. Let's review. And then x times x is x squared. Same idea is what you're going to apply here. So 3 times 2 is 6. I times I is I squared. But you got to rewrite this. You need to be able to simplify I squared. So note I squared equals a -1. So this right here becomes -1. So I get 6 times a -1, which is -6. So there's your answer. So 3i times 2i is 6i squared. And knowing that I squared is the real number -1, we get 6 times -1 is a -6. All right, number 7. Suppose we had 2i times 3 plus 5i. So 2i times 3 plus 5i. So just like when we had, let's say, 3x times 4 plus 5x, let's say, we use a distributive property. And so when I use distributive property, 3x times 4 is 12x, and then 3x times 5x is 15x squared. All right? And then remember, you couldn't combine these because these are not like terms. This has x to the first, this has x to the second. So the same idea is going to be used here. You're going to use the distributive property. So 2i times 3 is 6i, plus 2i times 5i, 2 times 5 is 10, I times I is I squared. So writing that step. Now you're not done, but that is a step you need to write. And then we know that I squared is just -1. So I get 6i plus 10 times a -1. So this becomes 6i minus 10. And now remember, they're going to ask you to put this in standard form. So in standard form, remember, standard form is a plus bi. So you put the real part first and the imaginary part second. So my real part's negative 10, and my imaginary part is 6. I'm going to write it as plus 6i. And so there's your answer there. So always make sure you put it in standard form. Right, number 8, suppose we had negative 6i times, let's say, 5i minus 2. Alright, well, again, using distributive property, so I have a monomial times a binomial, so two terms. So I'm going to distribute. So a negative 6i times 5i, so negative 6 times 5 is a negative 30. And then I times I is I squared. Alright, so negative 6 times 5 is negative 30. I times I is I squared. Now the next one. Negative times a negative is a positive, so there's going to be a plus. 6 times 2 is 12, and I get 12i. So a negative 6i times a negative 2 is a positive 12i. And then simplifying further, knowing that I squared equals negative 1, this right here, so I get negative 30 times negative 1. Remember, I squared is negative 1 plus 12i. And then negative 30 times negative 1 is a positive 30, so I get 30 plus 12i. And so there's your answer there. All right, again, let's review this one. So remember in a previous course, if I had 3 plus 4x times 2 minus, let's say, 6x, I can use the FOIL method because I have two binomials. So remember, FOIL. So 3 times 2 is 6. That's your first. The O stands for outer, so the terms on the outside. 3 times a negative 6x. 3 times a negative 6x is a negative 18x. And then I stands for the inner, so the terms that are on the inside. So 4x times 2 is a positive 8x. And then the L stands for multiplying the terms, the last terms of each binomial. So 4x times a negative 6x. 4x times a negative 6x is a negative 24x squared. And then combine like terms, I get 6. A negative 18x and a positive 8x is a negative 10x. And then minus 24x squared. Okay? The same idea is going to apply with number 9. Suppose I had, let's say I had 5 minus 2i times 6 plus 5i. Alright, so notice that in the previous two problems, I had a monomial times a binomial. So a monomial times a binomial. And here, I have a binomial times a binomial, so I'm going to use the FOIL method. So 5 times 6, first times first, that's 30. The outer, terms on the outside, 5 times 5i is 25i. Then the inner, the terms on the inside, a negative 2i times a positive 6 is a negative 12i. Now be careful with the next one. A negative 2 times a positive 5 is a negative 10, and then I times I is I squared. So I times I is I squared. Remember, x times x is x squared. So I times I is I squared. So you need to be careful when dealing with complex numbers. Now, combining like terms, these are like terms right here, and also using the fact that I squared equals negative 1, I can simplify this as 30 plus, and then 25i minus 12i is 13i. And then minus 10 times, and then I squared, remember, is a negative 1. Going a little bit further, I can simplify this further. You need to simplify this as much as possible. I get 30 plus 13i, and then negative 10 times a negative 1 is a positive 10. And then combining like terms and putting it in standard form, I get 30 plus 10 is 40 plus 13i. And so there's your answer. Okay, number 10, let's suppose we had this. Number 10. Suppose we had 6 minus 4i squared. So 6 minus 4i squared. It's kind of like when you had 2x minus 3 squared. So remember when you multiplied this binomial. So when you multiplied this, you rewrote it as 2x minus 3 times itself, because that's what that meant. So that meant you took the base and you multiplied by itself twice. And then you use a FOIL method. 2x times 2x is 4x squared. The outer, 2x times a negative 3 is a negative 6x. The inner, 3 times 2x is a negative 6x. And the last, negative 3 times a negative 3 is a positive 9. Now remember, one thing you learned when you squared a binomial was that the outer and the inner were always the same, because these binomials are the same. All right, and so when you combine like terms, you ended up with 4x squared, a negative 6x, and a negative 6x is a negative 12x, and then plus 9. So use the same idea here. So you're squaring this binomial, so that means the binomial times itself. So 6 minus 4i times 6 minus 4i. Rewrite it. Write in that step. So using a FOIL method, FOIL, and we're using FOIL here, I get 6 times 6 is 36. The outer is negative 24i. 6 times a negative 4 is a negative 24i. The inner should also be a negative 24i because I'm squaring a binomial. These two binomials are the same. So negative 4i times 6 is also a negative 24i. All right, now be careful with the last. A negative 4i times a negative 4i. Here's what I'm saying. Negative 4i times a negative 4i. So a negative 4 times a negative 4 is 16. I times I is I squared. That's what you have right here. So this becomes plus 16i squared. So negative 4i times a negative 4i is a positive 16i squared. And then simplifying this, this is 36 right here. I get 36. A negative 24i and another negative 24i is a negative 48i. And then this right here, remember I squared is negative 1, so this becomes plus 16 times a negative 1. And so I get 36 minus 48i. Positive 16 times a negative 1 is a negative 16. Combine like terms. 36 and a negative 16 is 20 minus 48i. So there's your answer. Okay, so that's going to take care of part 1 of complex numbers. So we talked about the basic terminology, we talked about adding and subtracting complex numbers, and we discussed how to multiply complex numbers. All right, so that takes care of part 1.